Hi everyone, welcome to Saturday Night SQL Virtual Group webinar. My name is Sarah Huang. Join me here is Debbie Huang, the co-organizer. I'm the founder and organizer of this virtual group. Today, Brad Llewellyn will present Azure Machine Learning Studio's 4 tips from the pros. As we mentioned in our previous webinar, Brad is a senior data science consultant at Centelli Solutions in Charlotte, North Carolina. Brad helps individuals and organizations unravel the data science world in order to figure out how it can work for them. He has an MS in statistics from the University of South Carolina and many certifications in data management and analytics, cloud platform and infrastructure, as well as machine learning. Brad is an active blogger at breakingbiblogspot.com. He also has he is also an organizer for the Charlotte BI Group, a local past chapter in Charlotte, North Carolina. You can connect with him through LinkedIn and on Twitter. We really appreciate Brad comes back and share knowledge with us for the third time. Let me first take care of the housekeeping stuff, then transfer screen over to Brad. Oops. Past Summit has announced the precons, and there are quite a few speakers like Isaac Bengan, Kendra Little, Brent Ozar, Bob Ward, Penel Davey, Kimberly Tripp, and many more speakers for the pre-con. And PASS will announce the general session speakers soon. As you may know already, PASS has a career center. You may want to visit pass.org/careers if you are a job seeker or an employer looking for talents. PASS is still looking to connect with new sponsors, and you will get an incentive for any referrals leading to community sponsors. And PASS Summit 2018 has a registration offer of 150 US dollars discount if you use our discount code VGDISP9II. These are the upcoming virtual group webinars for May, and I often join the DBA Fundamentals. I learn a lot from their virtual group, so I really like their webinars, and as well as many other ones as well. And PASS has many virtual groups with different topics, focus, or in different languages. And you may join as many as you like, and as always, you're more than welcome to join our virtual group, which is Saturday Night SQL. These are the upcoming SQL Saturday events, and you can visit SQLSaturday.com for more information and registration. And these are the benefits to join PASS to grow your careers. You may get online education event, which is free, and live webinars and in-person meetups, networking, volunteering, and speaking opportunities. This is how you may connect with the PASS. You may connect with the PASS through Facebook, Twitter, or LinkedIn. And this is how you may ask questions during session. Either raise your hand, one of either me or Debbie will mute you, or if you would like to interact directly with Brad, or you can enter your question in the chat window over here. Oops, here. And I'll read your questions to Brad. All right, that's all I need to go through, and this session is recorded and will be posted on YouTube soon, maybe tomorrow. Okay, let me transfer screen over to Brad. All right, thank you, Brad, so much for taking your Saturday and presenting for us for the third time.
Oh no, thanks for having me, and definitely thanks for all the people that are giving away their Saturday night to come learn something. So this session's called Azure Machine Learning Studio: 4 Tips from the Pros. And as she said, my name is Brad Llewellyn, and a large part of what I do is helping people kind of figure out what data science is and how it can work for them. And I'm a really big advocate of Azure Machine Learning Studio, because it makes data science accessible to people who it might not have been accessible to previously. So in this talk, we're going to spend, 30% of the time going through some slides and some fundamentals, and then we will spend the rest of the time in a demo, basically walking you through how I would, in practice, solve a problem using Azure Machine Learning Studio. So before we get to that, a little bit about me. I'm a senior data science consultant at an organization called Centelli Solutions. We're a data science consultancy here in Charlotte, and we do a lot of advanced analytics work around Hadoop and occasionally Azure Machine Learning Studio if the need fits. I have the plethora of certifications you can see up there. I'm a huge advocate of certifications. So if you're looking to advance your career, looking to learn something new, certifications are honestly the best way to do that. And many employers will actually pay for them for you. So definitely look into that if you're looking to advance your career. I've been an analytics consultant for 5 years or so. I've been at Centelli for actually probably 2 or 3 months now, but it's still relatively new. If you like what you hear today, you can find my blog at breakingvi.blogspot.com. You can also find me on Twitter and LinkedIn, and there's my email address there if you'd like to email me. As we said, I'm one of the organizers of the Charlotte BI group here in Charlotte. So if you live here or are traveling through on the first Tuesday of any month, come stop by the Microsoft campus and check us out. We talk about all sorts of subjects. Azure Machine Learning Studio is one of those. We also talk a lot about Power BI and SQL Server. And I'm also a frequent member and speaker of past webinars, so you may have seen me around. With that, I do want to thank the Saturday Night SQL virtual chapter for having me and letting us all get together to talk about this. Another thing I'm a huge advocate of is community involvement. I can say that I've been getting more and more involved in the community over the past 2 or 3 years, and it has accelerated my career drastically. And it honestly just makes me feel better about the stuff that goes on in my personal life. So if any of you are looking for one of those things, I highly recommend that you get involved in the community. I know that there are many of the past virtual user groups that are looking for people to speak, as well as looking for people to help organize. You can even start your own virtual group if your need isn't met. And I know there are going to be local groups in your area that would love your help as well. So finding a way to give back is great. Also, a bit of news, I guess, that hasn't quite cropped up yet. There's going to be something called the PASS Marathon for Predictive Analytics here in about a week and a half. I'm going to be one of the speakers at that. I don't know who the rest of the speakers are because I don't think registration is live yet. But it's going to be some type of 24 hours of PASS thing. I don't know if it's going to be 24 hours, but it'll be focused on predictive analytics. So you'll get talks like this. You'll get talks about Python and all that stuff. If you're interested in that, definitely keep an eye on pass.org to see when that comes out. So with that all out of the way, let's set the ground for what we're going to talk about today. We're going to talk about data science, specifically how to accomplish it in Azure Machine Learning Studio, but let's slow down a little bit and kind of level set on what data science is. So data science is a huge buzzword, and depending on who you ask, it can mean very different things. So for what we're going to be talking about today, I like to use the Gartner Advanced Analytics Maturity Lifecycle, I think is the name of it, to illustrate the point. A brief overview of what this is. Organizations typically start at the bottom and work their way up. It's pretty rare to skip a step here. It's almost required that you go through the steps in order. And the order starts at the bottom, where organizations just start asking questions like, can you tell me what happened? Who did we sell to last week? What did we sell? Who were my customers? Basic questions like that. Then once they get a handle on that, they move on slightly more advanced questions, like why did it happen? Why were sales down last week? Why were sales up last week? Why didn't this customer buy from me? Why did they buy from me? Those sorts of questions. Then once you get even more advanced than that, you can start moving into the predictive space. So start asking what is going to happen. A lot of forecasting goes on here and budgeting. How much do we expect to sell next month? How much do we expect to sell next year? Which products should we be selling? Those sorts of questions. And finally, when you get sufficiently advanced, you can start asking the prescriptive questions. So what can we do to make these things happen? What customers should I be selling to? How can I interact with these customers to increase their likelihood of buying? Those sorts of questions. So when we think about this, I like to think that data science is the top, 40 or so % of this. It's definitely everything in the predictive and prescriptive space, but there are also really interesting applications in the diagnostic space for it. For instance, IoT does an awful lot of looking at, can we use predictive algorithms to determine why machines are failing and that sort of stuff. To get rid of that buzzword, because it is such a buzzword, throughout this presentation, I'm going to try to call it advanced analytics, because that seems to be a bit more of a truthful term, but I may slip up, so please don't take offense. With that, I'm going to give you 60 seconds or so to read this scenario. This is what we're going to be doing today. So this says that Contoso Technologies Incorporated, CTI, is an online technology retailer. When the users sign into their site, they fill out a form with basic demographic information. CTI wants to use this information to predict the user's income. This information will be used to determine which products the users should be offered on the site. Pretty simple question. User logs in. Can you tell me how much money this user makes? And we're going to follow this from beginning to end, how I would actually solve it if I had this problem in real life. So the way we're going to do that is by looking at 4 different areas. And we'll walk through each of these individually. The first one we're going to look at is letting the data decide. And this is a big one. It's honestly my favorite thing about Azure Machine Learning Studio, and especially if you've seen my intro presentation, we talk about something like this a lot. In order to illustrate the point of what does it mean to let the data decide, I did a Wikipedia search a few months ago and just said, how many regression algorithms are there? If I just look up regression, how many do I get? Tons. There are, and this is just a snippet of it, there are literally hundreds of regression algorithms. In order for us to be traditional data scientists, we have to know all of them, right? Well, not all of them, but we'd have to know a large portion of them. We'd have to understand how to use them, what goes into making them, which ones are better than others. That's a lot for us to know, and it's a really steep curve, one that people without PhDs might find daunting. In fact, this list is so long that I actually added a few Pokemon to this list, and most of you probably didn't even notice. So there's so much in this field that it's very difficult for us to know what we should be choosing if we don't have something to kind of help us along the way. So with that in mind, let's think about what a traditional data scientist does when they approach a problem. And I like to illustrate it with just this one picture, which I lovingly stole from the movie The Hangover. So I work with a lot of traditional data scientists right now, and they do a lot of math. There's a lot of really hard programming they have to do, and it is daunting looking from the outside of, if I don't have that knowledge, can I do this job? And the answer is yes, and we're gonna show you today how. But there's a lot of math involved. So if there was a tool out there that could really take a lot of that away, make it so that data professionals like you and I can approach the problem, that would have a lot of value for organizations. And honestly, that's what Azure Machine Learning does. So the way I like to look at it is, if we let Azure Machine Learning do all the work, and we let the data tell us what the right answer is. Letting the data decide means I don't come in and say linear regression is the right answer. I don't come in and say logistic regression is the right answer. I let the data and the tools tell me what the right decision is, because my data always knows more than I do. So I like to look at it as Azure Machine Learning really opens up the world for me so that I can go to the water park with my family, because that's what's important, instead of sitting around doing hard math all day. With that in mind, we have these two different types of data scientists here. We have the traditional data scientist that spends a lot of time working in math on really hard problems, stuff that I personally am not smart enough. And then we have those of us that really leverage the tools and the data to make the work easy for us so that we can go do more fun stuff. That really leads to the question of, what is a data scientist going to look like in the future, in 10 years or so? And the obvious answer is Terminators, because we are building the algorithms right now to do all the work for us, and eventually they will take over and destroy us all. But until then, we have work to do. So let's take a look at what that work is. That was a bit of a joke in that first section, but I do want to emphasize that everything we're going to do today is letting the data make the decisions for us. You're not going to see me make any assumptions today at all. The data here is going to absolutely tell me what the right answer is, and I'm going to do nothing but let the tool do the work for me. And that's what we'll see. So the first real thing we're going to talk about here is tune model hyperparameters. It's really the backbone of the way I let the data decide. So let's talk about what that is. While we think about that, we need to ask ourselves, why does predictive modeling take so much time? You know, I work with data scientists that'll say we need 12 weeks to build a predictive algorithm, 12 weeks to answer one question. Why? What's so hard about answering one question? Can't we just look at the data and let it tell us? Well, it's more complicated than that. So, like we saw in the previous section, there are hundreds of different types of models to use. Really, there are thousands of different types of models that we could use. And that number is growing every day. On top of that, each of these models has what are called hyperparameters. So, excuse me, if you think about something like a neural network, you don't just say, hey, I want to apply a neural network to my data. Neural networks have layers and nodes and all sorts of complex math stuff that goes into them. So those have to be tweaked and messed with. So those just explode the number of combinations. On top of that, a lot of our time spent cleaning our data. So when you're cleaning your data, there's a bunch of different ways you can do that as well. So when you combine all this together, you really find out that there are just an incredibly large number of paths to solve the problem. And that's what traditional data scientists spend a lot of time digging through manually. They dig through a lot of these model types. They make assumptions, they test, they build different algorithms, and it's very time consuming. At the end of the day, it's a lot of work. So can we leverage Azure Machine Learning Studio to do this for us? I gave away my own punchline, unfortunately. But so the real question here is, what if the computer did all this work for us and we got to go to the water park with our family? So let's look at what that is. I'll hop over to my web browser. I already have it open. You can see my Azure Machine Learning Studio here. For the first experiment, we're just going to do a little bit of a dive into our data so that we can see what we're working with. If you remember our scenario is we're trying to predict a user's income. So we have a set of training data here. We have a set of data that we can use to build our model that we can then deploy out to our website to predict users' incomes for us. So let's take a look at that data real quick. This is the sample data set provided with Azure Machine Learning Studio, called the Adult Census Income Binary Classification Dataset. It's a mouthful. With this data set, as we see in the top left, it has 32,000 rows and 15 columns. These columns are basic demographic information. We're going to assume that when a user logs into our website, they give us all of this information. In practice, you will have something like this. You may not have this exact information, but you have something about your users that you can use to build your model. So we use the data we have at our disposal. And at the end of this data set, what we're really concerned with is this column here, this income column. We can see it takes two unique values. Those values are less than or equal to 50K and greater than 50K. Our goal is to predict that. Let's say we have two products we're trying to sell. We have our luxury product that people that have an income of less than or equal to 50,000 can't afford. So we don't want to show it to them. We also have a very budget conscious product that the people with higher incomes might not want to purchase. So we want to show the right product to the right customer. This may sound very familiar to what Amazon's really famous for. Their customers like you also purchased thing is a very advanced version of something like this. So we're going to roll our own here in the next hour. Before we do that, as those of you who may be veteran users will know, or if you've seen the intro presentation, we can't just use our raw data as it is, because there are two phases to building a predictive model. There's the training phase, meaning taking that empty model, that empty math formula, and using our data to fill it in. And then there's the testing phase, also known as evaluation. And that's where we determine how good our model is. At the end of the day, we want to build the best model possible. In order to do that, we have to be able to define what best means. And the reason we like to separate these two data sets out is because it's not fair to test the model using data it's already seen. When the model's trained to know how much these particular people make, so it wouldn't be fair to ask them how much a person makes that it's already seen. Instead, we want to show it a new person. Because in practice, that's exactly what's going to happen. A new person it's never seen before is going to log in. And we have to be able to predict that person's income. In order to do that, we do what's called splitting the data, and Azure Machine Learning has a great split data module we can do for that. And here we're just saying I want to use 70% of the data for my training set and 30% for the testing set. So with that, we'll move on to the next step. The next step is, like we talked about, it's tune model hyperparameters. So tune model hyperparameters takes three inputs. This input here on the left is the untrained model. So in this case, if you look over on the left, you can see we're using two-class boosted decision tree. We're just picking something right now to showcase functionality. At the end of this presentation, I will actually show you the production experiment I would build that solves all of this for me in one click and I go home. But until then, we do have to lay out the fundamentals. It also takes a training data set, and we just explained what that was, as well as a validation data set. That's that testing set we talked about. And fortunately, split data allows us to make that in one go. So what does tune model hyperparameters do? We open up the properties over here. It has something called a sweeping mode. Basically, tune model hyperparameters is going to train this, in our case, two-class boosted decision tree algorithm. It's going to train this model more than once. In fact, it's going to train it 5 times, as we see here. Maximum number of runs is 5. And in order to train it 5 different times, it needs to give it 5 different sets of hyperparameters. So let's back up a second. What's a hyperparameter? We kind of mentioned it before, but let's look at them. For two-class boosted decision tree, we have a few different hyperparameters over here. We have something called maximum number of leaves per tree. For those of you that know a little bit about decision trees, they're made up of leaves and trees, basically. So the number of leaves per tree is basically how dense a particular model is. And then the number of trees, which is another hyperparameter down at the bottom. The number of trees is the number of those trees you have. So you could have a small number of very dense trees making your decisions, or you could have a large number of very sparse trees making decisions. And those are the types of questions that a traditional data scientist would have to know the answer to. But for us, we're going to let the data decide, remember? So let's see that in action. Going back over to tune model hyperparameters, the last couple of pieces we have to specify here is the sweep mode at the top. So the sweep mode is how does it choose the hyperparameters it runs on? There are two main ways to do this. We can supply a set that we want it to run, what's called a grid. And we can supply that grid and tell it, I want you to run the whole grid, or I want you to run a random sample of the grid. Or my favorite, use random sweep. Random sweep basically says, I'm going to let you pick 5 random sets of numbers. They're not actually random. There's a pattern to them, but that's not important. 5 random sets of hyperparameters and create models off of it and see what happens. We'll often find that unique combinations of hyperparameters really build the best model. And those sets are ones that we probably wouldn't be able to divine out of our head. So letting the data decide really helps here. And finally, we have to define a label column at the bottom that tells it which column we're trying to predict. In this case, we're trying to predict the income column that we saw. So let's look at the results of this. I've already run it to save us time. So the first set is the sweep results. So we look here, and it gives us our 5 different models here. So notice we have 5 rows here. It tells us the number of leaves it tried in each model, the number of leaf instances, and we're not going to worry about what that is, as well as the learning rate and the number of trees. So we can see this first one up at the top has 6 leaves per tree, so it's a very sparse tree. It's not very deep, but it has a lot of trees, a lot of very different trees. Or take the third model, for instance, has 59 leaves per tree. Very dense tree, but not very many of them. So which one's the best? It has all of these metrics over here to the side. These metrics are calculated for every model it trained. We won't get into in this presentation exactly what these metrics do, but this begs the question of how did tune model hyperparameters know which metric we wanted to use? Did we want to use accuracy or precision or recall or F? Well, we actually told it. I didn't bring it up then, but if we scroll down a little bit, we see down here at the bottom, we have the option of choosing here. So it has 2 different drop downs, one for classification models, when that's the case we're in, and one for regression models, which would be a different type of question. So you can see here, we told it accuracy. So if we go back to our visualization, we can see that tune model hyperparameters pick 5 random set of hyperparameters and ran the models, and it sorted them based on their accuracy. So we can see the top model has the best accuracy at about 86%, and the worst model has an accuracy of 85%. Not a huge difference, but at the end of the day, sometimes minor percentages matter. Again, this is just a showcase of what tune model hyperparameters is. So it's not super important to worry about these numbers just yet. We will later on. So with that in mind, just a small recap of what we just did. Instead of us coming in and saying, I'm going to use 2-class boosted decision tree, and I know exactly what my number of leaves per tree needs to be. I know what the number of samples needs to be. I know what the learning rate needs to be. We don't know any of that. We're not omniscient. We don't get to know that, and it's different for every data set we'll ever run. So we let a random algorithm, basically, and our data tell us what the truth was. And you'll see that it has a recurring theme. This is just one piece of the puzzle. This piece of the puzzle here lets us determine, for a given model, which set of hyperparameters is best. So it lessens that amount of work just a little bit. Let's see what's next. So we've shaved a little bit of time off of our plate. Job just got a little bit easier because now we don't have to deal with hyperparameters. But there's a lot more to the job than that. So the next thing we're going to talk about is postponing feature engineering. Before we get into that, we do need to level set on what is feature engineering. Feature engineering is a very common part of a traditional data scientist job. In fact, it's probably the majority of it. So the goal of feature engineering is to improve model accuracy, and accuracy could be in quotes there because it could be precision or recall or any of those other metrics, but improving the model's performance using the data you already have. We're not introducing any new data. We need to make our model better simply by changing the data we have. So how can we do that? We can create new fields out of our data. We can aggregate or combine some of our existing fields. So in time series cases, you'll often see things like, let's look at today's sales and yesterday's sales and the day before sales. Most data sets only have sales per day. So a data scientist, in this case us, would come in and create those new fields. That's feature engineering. You might also find use cases for taking the square of a field, or taking the square root of a field, or any number of other mathematical functions we might want to do. There's also use cases for combining fields. For instance, if you've got two different string values. So in our data set, we've got education and work class. Education tells us what level of education the person has, and the work class tells us what industry they work in. We could actually combine those into a single field called education and work class, and that might give us different modeling results because of some quirks in the math. So those are all the ways that a traditional data scientist would approach the problem. The issue here is the cycle. So if we look at the cycle here, data science or advanced analytics always starts with collecting data, bringing our data together, and we can't avoid that. Everybody's going to have to do that all the time. That's a natural part of the job. Then they spend a lot of time in the data cleansing, and that was one of our big things that takes time. They spend a lot of time in feature engineering. The interesting thing is they do this before a model's ever been created. They have no idea how good a model would have been without the features. In fact, I've talked to some traditional data scientists that are just thoroughly convinced you can't do a project without those two things. You can't possibly build a model without data cleansing and feature engineering. And they may be right, they may not. The thing is if I could build a model in a week that solves the problem well enough, do we really need to spend the additional 7 weeks on data cleansing and feature engineering to gain an extra 2% model accuracy? That depends, and that's what we're going to talk about right now. So something I generally propose is those may be needed processes. We definitely don't throw them away. But why don't we postpone them? What if, instead of doing data cleansing and feature engineering first, what if we built a model right off the bat and said, just show me what the model would be like today. No cleansing, no feature engineering. Using the data as it is, how good would our model be? Just using the data we already have. Then we get to make some interesting decisions. For instance, I once built a model just off of raw data that was so bad. It was actually worse than the flip of a coin. It was so incredibly bad that it told us right away, we don't have the data we need to solve this problem. We can't tweak our data out of this. Instead, we need to go back to the drawing board and completely figure out a new way to solve this problem. So we saved a bunch of time doing what's called fail fast. On another case, I also found myself in a situation where our initial model was so good, we didn't even iterate on it. We said, honestly, it's not worth the additional effort to get an extra couple of percentage points out of this model. It's better to keep the model as it is and move on to use our time on something else. And that's the real advantage here. That's why we call it the Agile data cycle, because it iterates. You start as quickly as possible, and then you add the additional things you need instead of doing it all up front. So let's look at what that looks like in Azure Machine Learning Studio. Going back out to our experiments, we go to step 3 here. We've added a few things here, so we'll walk through what it is. Notice the bottom It's pretty similar to what you've already seen. It's got the split data and the tuned model hyperparameters and the two-class boosted decision tree. There's a lot of new stuff going on before that. So let's look at that. First is this edit metadata thing. And this is nothing more than a quirk of Azure Machine Learning Studio. In order to convert to indicator values, and we'll get to that in a minute, in order to convert to indicator values, your fields must be categorical, and string fields are not by default categorical. So you'll get an error, and to alleviate that error, you have to use edit metadata and make categorical. Nothing special there. After that, we did a little bit of data cleansing. And this data cleansing basically just takes work class, occupation, and native country, and it replaces them with the word unknown. This was just a personal thing of mine. I don't like nulls in data sets unless they need to be there. So I'm a proponent of just even right off the bat, just replace your nulls with unknowns. That doesn't apply to numbers. Please don't replace nulls with zeros if they're numbers. But for strings, as long as unknown isn't another value completely, replacing nulls with unknowns is generally something smart to do. After that, we did some convert to indicator values. And we did this for a very specific reason that we'll see in a minute. But convert to indicator values, it creates what are called indicator values or dummy variables or one-hop processing off of our data set. So let's look at our clean data real quick to see what it looks like before it goes in here. We have 15 columns. Some of these are strings. Work class is a string, education is a string, marital status is a string. But there's 15 columns. Convert to indicator values. We told it, take all the categorical variables. We defined them as categorical earlier. Excluding income. We don't want to mess with our label, our dependent variable as it's called. So what comes out of here? Once this decides to open, there we go. Notice at the top, we have 109 columns now. Something major just happened here. If we look down at our data set, now instead of having a single column for work class, we have work class federal gov, work class local gov, work class never worked, work class private. What that convert to indicator values did was it replaced all of our string, or in this case, categorical values, with one column per unique value. And this definitely had an effect on our number of columns. We have 109 columns now instead of 15. But what it did was it opened up a really interesting option to us. It doesn't really change the results of our tuned model hyperparameters, because tuned model hyperparameters was already doing this anyway. When you train two-class boosted decision tree, it actually does this on the back end. What it allowed us to do was use this one at the bottom here, called permutation feature importance. Something that's always bugged me about feature selection and feature engineering is you don't get to see the impact that your new features or your existing features have on your model. It's done before you've ever trained a model. So it usually involves a lot of, let's say, we want to see the impact that work class has on income. So we'll turn work class into a number and we'll do what's called a correlation. We'll see in a vacuum, just by themselves, does being a federal government employee have a positive or negative impact on your income? Does being a local government employee have a positive or negative impact on your income? But in the real world, things aren't so cut and dry. Looking at things in a vacuum doesn't help us because things are complex. For instance, I could be a federal government employee and be a highly paid member of Congress making hundreds of thousands of dollars a year, and that would be great income. Or I could be a federal government employee that works in a much lower paid department and have a low income. So being able to combine my work class with some other things, like my education or like my age, would build a much better picture. But a lot of the traditional algorithms don't allow us to ask questions like that. So it misses a lot of the picture. So if we allow ourselves to build our model first, and here we built our model first using tuned model hyperparameters. Notice how this is building. We've chosen the best two-class boosted decision tree by randomly choosing hyperparameters. Now we're going to use what's called permutation feature importance. We're going to effectively look at what impact each variable has on the model as a whole. Meaning, what impact does work class have on income in the context of everything else, not in a vacuum? Because at the end of the day, our goal is to make the best predictive algorithm possible, not choose the best features that happen to have a good correlation with the dependent variable. So let's look at what we get out of this. We get out of this 108 rows. Notice that's the exact number of columns we had. We had 109 columns, but I don't think it includes income in here. I think that's the difference. Don't quote me on that, though. I'm not positive. But what it does is it assigns a score to each of our features. And this score is how much of an impact this feature has on the model. It answers that exact question we were saying. So we see in the context of all the other information we have, capital gain is important. Marital status, married, civ, spouse is important. Education number is important, given everything else. We've let the data tell us this. I'm not coming in and saying this. Remember, this whole thing is built in. We're letting the data decide. We're using tune model hyperparameters. And now, straight off the bat, we are now letting it tell us which features are important. We can even scroll to the bottom and start seeing a lot of interesting stuff. Like we got some negative ones down here at the bottom. Like occupation protective service actually has a negative impact on the model. The model's worse because we include this value. This variable is so noisy or so awkward in some way that it makes our model worse. So we should definitely take it out. The same thing with education doctorate. And there's also a number of values here that just have no impact on the model. They're just a waste of time. And that can allow us to either speed up our model or, more importantly, it educates us moving forward. Most of the time we're going to be iterating. So if we can narrow our list down from 108 columns to whatever 20 columns are here, that really allows us to decide then, do we need feature engineering? Do we not need feature engineering on a much smaller set of columns? Again, letting the data decide every step of the way. I will give a small caveat here in that Azure Machine Learning Studio has a display issue here in that these are not actually zeros. They're just very small numbers. So if we were to remove every single column here that has zeros and just run the model on the columns that have positive values, our model would be worse. So often I say remove them a couple at a time. Definitely we'll remove the negatives and then start removing them one at a time until your model kind of peaks. And that's one of the things I do. We're not going to do that here because we're on a bit of a time crunch. So this is just another way that we can allow the tool to do the work for us. Remember, I haven't done anything here except drag some stuff on a screen and let it choose the hyperparameters for the model and let it choose the columns. I haven't used any of my own knowledge to accomplish this, which means it saves time and honestly gets a more accurate result at the end of the day. So let's move on to the last piece of the puzzle here. We're going to talk about extending our Azure Machine Learning Studio capabilities using SQL, R, and Python. Before we do that, let's talk about the data science space as a whole. So the data science space is really broad, as we talked about. There were 100 regression algorithms we showed earlier in this thing, and nobody knows all of it. No tool handles all of it. No problem exists in all of it. In fact, Azure Machine Learning, or Azure Machine Learning Studio in this case, covers a pretty narrow part of that. It's very difficult to, just using the GUI, solve the majority of business problems. You might be able to solve a couple that really neatly fit, but for the most part, I've never in my entire time using Azure Machine Learning Studio, and I've used it on a number of projects, ever solved a problem just using the GUI. I almost always have to use SQL, R, or Python in some way. And that's what we're going to talk about here. It really expands how much we can use it. In fact, I run in circles with a number of other people who are Azure Machine Learning advocates, and the general consensus we have is that About 80% of all analytics problems can be solved by Azure Machine Learning Studio if you include SQL, R, and Python integration. Meaning that only 1 out of every 5 problems that our organization has, data problems that is, needs a more advanced tool. 4 out of every 5 problems can be solved by us letting the machine do all the work and go to the water park. So with that in mind, what can we do with SQL, R, and Python? They're both used for data manipulation. I'm sure most of you here have a good knowledge of SQL, seeing as how that's the backbone of PASS as an organization. R and Python, maybe not so much, but R and Python are basically programming languages. They're not really similar to SQL, but they can do data manipulation in a slightly different manner. They can also be used for feature engineering. That's often what you see it used for. You can use the Azure Machine Learning Studio GUI to build new features and stuff like that, but personally, I find it cumbersome, and it's just easier for me to use SQL, but that's personal preference. The difference is what type of features they can make. So SQL, as I'm sure most of you are really good at, or have a strong understanding of, SQL is really good at cross-data set and aggregate features. SQL really loves joining tables together and grouping things. R and Python, on the other hand, they don't really love doing that. They can, but it's not really where their forte is. So their strength is in time series and rolling features and things you would generally expect a programming language to do. So looking across your data set is what they're really good at. R and Python also has the added advantage of they can actually build models. I've seen production use cases where we don't use any of the pre-built models in Azure Machine Learning Studio. Instead, you can import additional libraries directly through the studio using zip files. And they'll import those R or Python libraries and let R or Python build the predictive model for us and use Azure Machine Learning Studio as a means of creating an easy API. I've seen that as well, and that's another good use case. So with this in mind, one more tip. The SQL we see in Azure Machine Learning Studio is not T-SQL. It's a language called SQLite, which is SQL 10 years behind, basically. So it doesn't have a lot of the interesting functionality like windowing functions and things like that, but it does have the same core functionality of joins and whatnot that most of you should be able to pick up very quickly. So with that, let's get to the rest of our demo. The last piece of our demo. Looking at what we've accomplished so far. We've brought in our data. We've used tune model hyperparameters and permutation feature importance to tell us what's important for one model. Remember, only one model has been used here so far, 2-class boosted decision tree. Let's do a little bit better job with R, SQL, and Python. In fact, we talked about feature engineering before. Let's do that. So we've used permutation feature importance that tells us what features are and aren't important to our model. And we've added an R script right here. Let's take a look at it. So this R script, I'm not going to walk through the whole thing here. We're going to start using a lot of scripts in this presentation. And you can find all of those on my blog. There's a post back in January called Azure Machine Learning Webinars. And I'll also send the link out to the organizers after this presentation so they can send it out to you guys. But in this script, we're doing a few things. First, we import all the data in. And then we loop through all the possible combinations of our data. Remember, we have 109 columns at this point, 108 columns, something like that. And we're looping through all the possible combinations of our data to create what are called interaction variables. So interactions can be defined in a number of different ways, but most commonly, they're multiplying. So we've got a bunch of 1-0 columns at this point. We have a bunch of columns like work class federal gov, work class state gov, work class unemployed. And those take 1 and 0 values. So mathematically, if you wanted to know whether a person has both of those things, if you want to know whether a person has a work class of federal gov and an education of doctorate, what you would do is you would multiply the federal gov 1-0 column by the education doctorate 1-0 column. And that's effectively what we're doing. We're just using R in Python to loop through our data set. Think this would be very difficult to do in SQL because SQL's, especially SQLite, doesn't like loops. In fact, I'm not even positive it's possible in Azure Machine Learning Studio's version of SQLite, but it's very easy here because R and Python love loops. So we combine them together by multiplying. You can see that right here in the middle of the screen. And then we output that data back out. Pretty simple, basic feature engineering. So if we look at what comes out of this, we now have 9,120 columns. I will admit, a little overboard. Again, this is a showcase of functionality. Please don't do this in production. Please don't take 100 columns and multiply them all by each other. You would definitely iterate on this. You would use what you learned from your permutation feature importance to determine which columns actually make it into this algorithm, to pare it down a lot. We'd pare it down to those top 20 and then do interactions on just the top 20. So we'd get 20 times 20, which is what, 400. But in our case, we have 9,120. Fortunately, Azure Machine Learning's not scales pretty well, so it's not a major problem. Again, just to showcase a functionality, please don't do this in your production cases. But this was just a way to show how we could really extend the functionality of Azure Machine Learning Studio using R in this case. And we're going to use SQL here in a minute to do something even more interesting. So we've now done all the major features of model building. We have built a model, and we can validate it using our two model hyperparameters. We've done feature selection with permutation feature importance. We've done feature engineering with our R script here. And we've done data cleansing with the clean missing data module, which we didn't talk about a lot. So how do we piece all this together? How do we make a real production experiment that I would be willing to show to a customer and say, this is me solving the problem you paid me to solve? So let's look at that, the last step here. We're gonna have to zoom in because this is where it really starts to get complicated. So if we look up on the, I'm gonna zoom in with the UI. Maybe that'll be better. There we go. So if we zoom up to the top, we have all the same things we've seen before here. We've got our input data, our edit metadata, our R script, and all that. This is what we've seen before. Remember, the goal here isn't for me to tell Azure Machine Learning Studio anything. I want to create an experiment that takes me a few minutes to put together. I want to click the run button and I want to go to the water park. I want Azure Machine Learning Studio to use all of its fanciness and to let the data make the decisions on what is best here. Can we do that? And the answer is yes. Well, in order to do that, remember before, we only used one model. So I'll zoom out just a smidge so we can see. We used one model, and that one model was two-class boosted decision tree. I've got 14 models here. And those 14 models are every single two-class classification algorithm in Azure Machine Learning Studio that can be used by two model hyperparameters. You'll notice that some of these are repeated. For instance, two-class locally deep support vector machine. There's actually 3 unique combinations of this that can be used. And it's all based on this feature normalizer down here. So basically, using a binning normalizer, a Gaussian normalizer, or a min-max normalizer results in 3 completely different answers, and we want to test all of them. So we use all 14. It's really not hard. Copy and paste is our friend here. So put all this together. It takes maybe 15 minutes to drag all of this stuff onto the screen. We connect every tune model hyperparameters to one of the models and the same input data. Remember, we split the data once. It's the same training and testing set going into each of these. So it's going to tell us, for this training and testing set, what is the best possible model. Notice our maximum number of runs here is 20 runs per. So we've got 14 algorithms by 20 runs each. So we've made 280 different algorithms. 280 different runs to see, out of 280 possible algorithms, what's the best? What's the best possible one for my problem using my data? Now, this results in 14 different outputs that we have to string together. I've got some SQL queries. Remember I said we'd use SQL? I wrote some SQL queries to really bring all this together. These are on my blog as well, so you're more than welcome to look at them. I use a bunch of SQL queries to bring it all together. And at the very end, we have a convert to CSV so we can drag it out. I like to use Excel to examine this. But for us, we'll just look at it in the editor here. And what we see is up at the top, we see our best possible algorithm is 2-class boosted decision tree with 33 leaves, 9 leaf instances, a learning rate of 0.047, and 146 trees. And that algorithm has an accuracy of 86%. This is not sorted, so we should have sorted this. Wait a second. So yes, that would be sorted. One of the other reasons why I use Excel, and I would need to add that to my SQL transformations here. But assuming this was sorted, then our top result here would be our best algorithm for 280 different runs we see here, the best possible result. So we'd be able to see that right here. Just for kicks, let me pull this out. So that's another feature of Azure Machine Learning Studio, is you can bring them out to CSV. So just to get the final answer here, so I don't want to leave you guys hanging. We will bring them all out, and we'll say, show me the one that has the best possible accuracy. So best possible accuracy is a 2-class boosted decision tree with 18 leaves, 1 leaf instances, a learning rate of 0.054, and 98 trees. Out of 280 possible algorithms, this has the best possible accuracy. In fact, we've got some other metrics here, like precision and recall and whatnot. We can do this for any of those metrics we want. So we've effectively let Azure Machine Learning Studio and our data do the entire job for us, tell us exactly what model gives us the best possible result, and it even tells us how accurate it is. So now we can make the decision of, is this good enough? Or do I need to do more work here? Or should I abandon this completely because we're nowhere close? So that's actually how I solve these types of problems in production cases. When I'm talking to real customers, I do things like this. Granted, there is more involved on the front end. We define problems and that sort of stuff. But this part of the process, the model building process, shouldn't be where the hard work goes in. And that's what the point of this was, to really show you how to maximize what you can get out of Azure Machine Learning Studio. So I hope you got a lot out of it. Thanks so much for your time. I really hope this is something you can take to your job tomorrow and really be able to showcase some value, because I really do believe that Azure Machine Learning Studio is one of the easiest ways to get quick value out of easier problems without needing to have a lot of R and Python skills to back it up. So at this point, I'm open for questions.
Yeah, we have several questions. George was asking, how valuable is this? I guess how valuable is this predictive stuff? I was watching a show and they said predictive stuff only works if things stay the same, roughly. For major events, the .com bust, housing bust could have never been caught by predictive analysis. Also, can Azure access the AlexNet?
So to answer the last part of the question, can it access AlexNet? I can't say for sure that it doesn't. I want to say it can't, but you're more than welcome to test that on your own. As far as your assertion that there are weaknesses to predictive modeling, yes, there are absolutely. In fact, I have some coworkers that are working on a predicting steel prices, which interestingly enough have been going crazy recently because of some of the stances by the current administration, and their predictive algorithms are having some trouble keeping up with that. But if you want to see the value of predictive analytics, just look at Amazon. I mean, honestly, companies like Amazon, like Microsoft, like Google have basically bet their entire companies on predictive analytics, and they're the biggest companies in the world now because of it. I mean, there is value there. It is the future, and while it doesn't catch everything, it's not perfect. It's getting better, and while it's not perfect, it's still 100 times better than people. So, I mean, yes, oversight, but there is certainly value there.
Yeah. I guess I'll rephrase his next question. Would you be able to, do you by chance know the salary range if somebody has a bunch of certifications like yours, working for on the data science side?
I mean, that really depends on your area. I mean, I know for a fact there are data scientists at Microsoft that make over $500,000 a year. With that said, I don't do it for the money, and you're not going to get the certifications and all of a sudden get massive salary like that. But I mean, data science is the future, advanced analytics is the future, and certifications are a great way to get there. So salary or not, it's the best career decision you'll ever make, and that I can promise you.
That's true. Yeah, Jeff was saying that he appreciate your wonderful presentation. Is machine learning MS Machine Learning Studio free to install?
Yes, actually, I've on YouTube from this exact virtual group. You can see a presentation I gave a couple months ago. That's an intro to this. So it absolutely is free. You don't even have to install it. It's on the web all the time for you. So definitely look that up. And if you want to try yourself, just Google Azure Machine Learning Studio, and it'll take you right to Microsoft's page where you can sign up for it.
Okay, thank you. Also, another question. It seems that you spend a lot of time in data stuff such as data cleansing, and the rest jobs are done by the model embedded in Azure Machine Learning Studio. Is that right?
Yes. So one of something that, depending on your perspective, is either a positive or a negative of Azure Machine Learning Studio, is the modeling itself. The actual building of the models is not in your control. It does mean it's fast and it's very easy for people who might not have a strong understanding of those models, but it does mean that there are use cases where you can't get it to do what you need it to do. And that's that 20% we talked about earlier. That's that 20% of problems where it might not be the right solution.
Right. So another one is, can I download or run the project shown in the demo?
So there's no real way to share this among people without literally inviting you to a workspace and letting you copy and stuff like that. That's as far as I'm aware, that's a downside of Azure Machine Learning Studio. But you can easily follow along here, and I didn't do anything major. And like I said, all the code that I used is on my blog, so you're more than welcome to look this up on YouTube and follow along on your own.
Yeah. So I think you mentioned that you'll be able to share the code, right? If
yes, I will send you a link after this is over to the blog post where I have all of the code and links and whatnot.
Okay, cool. I'll post it on our website so that our members, whoever is interested, can look it up. Thank you. Okay. Also, Mike was asking, we have a lot of EMR data which are not connected to Azure right now. What would you suggest for this case with data analysis, I suppose?
If I remember correctly, EMR is Azure or Amazon Web Services. With that, I do know that Amazon has something similar to this. I think it's called SageMaker, if I'm not mistaken. I've never used it, but one of the things we talk about in the earlier presentation is Azure Machine Learning really does want your data in Azure. So you could bring it down as CSVs and upload it manually to Azure Machine Learning Studio, or you could find a way to import it into either Azure SQL Database or Azure Blob Storage or HD Insight, which is Azure's version of Hadoop. Or there are other tools similar. I'm not telling you Azure Machine Learning Studio is the only answer. I'm just saying, why don't we use easier tools, of which Azure Machine Learning Studio is one of them. So if you have an alternative, please do.
Yeah. So if I guess he could find a way to import the data, then he can use Azure Machine Learning Studio.
Correct.
Yeah. Okay. Jenny was saying, I did not hear last question very clearly. What certificate is needed or helpful to get a job, to land a job in machine learning?
So I've literally got an entire presentation. I think I gave it to this virtual group. If not, I've definitely given it to a couple of others, called what is a data scientist and how do I become one? And it's literally an hour talking about that exact question.
Right.
But there are a lot of certifications out there, and I encourage you to look that up on YouTube because it does go into detail. But Microsoft has two major certifications around data. They're both what are called MCSEs. And here, I'll go back in my presentation real quick so we can see, because this is something everybody here should have at least basic knowledge of. Those MCSEs at the top, those are the only two that Microsoft currently offers related to data. Data management analytics is a lot more on the analysis side, and cloud platform and infrastructure is more on the platform side of things, so creating resources and whatnot. And you'll see I have a few MCSAs under that. You get an MCSE by taking a couple of tests, getting an MCSA in a very specific area. For instance, I've got some in SQL Server, Cloud Platform, and machine learning. There's the machine learning you were asking for. And then you get an MCSE by taking an additional test on top of that. So if you wanted to be a machine learning expert within Microsoft, you can get your MCSA in machine learning, which covers Azure Machine Learning Studio and R. And you can take an additional test to get your MCSE in data management analytics. And that's a great certification right there. And there are a lot of other possibilities you could go through as well.
Cool. After following that question, she also asked key classes or technical skills to do machine learning. What are the key classes or technical skills?
Again, this is exactly what that other presentation is. So please, YouTube, what is a data scientist and how do I become one? Because it's exactly what you're asking for. But yes, there are classes you can take and skills you can learn. To be a data scientist of some type, you definitely need to have strong technical skills, and attending presentations like this is a great way to build that. But it's too complicated to answer here in 2 minutes, unfortunately.
That's true. And you did the presentation in February for our virtual group. And
perfect.
Yeah, we do have a link. So yeah, I'll send. I probably will resend out the link for your previous presentation, so that if someone wants to relearn it or review that again, they have access to it.
Sure.
Yeah. So another one is like I think he wished to have the code than just a link. But I think that if I have your blog post link, they can easily find those codes you demo, right?
Yeah, it's on the blog, and I'll send you the link, and it's very obvious where it is.
Okay, wonderful. And yeah, Mike's previous question. Let me see what his question was. Yeah, he was the one mentioned that we have a lot of EMR data. That's what he meant. It's the healthcare data.
Oh, okay.
Yeah.
So is there another question there, or?
Well, let me see if he's available. Let me unmute him so he can ask a question directly. Hi, Mike. Would you be able to ask your question directly? I have unmuted you. All right. I guess he probably can't talk.
That's fine. If I remember his question correctly, he's asking, is there a way to get healthcare data into Azure? And I will say that yes, you can. I've personally worked with hospitals that use Azure. The entire Azure cloud is HIPAA compliant, and Azure has 70 security certifications for everything you'd ever need, and healthcare is definitely covered there. If you are a government healthcare entity, they also have something called the federal cloud, which is a completely separate Azure infrastructure from the public cloud. So yes, Azure can hold your data, and if you can get it into Azure, you can get it into Azure Machine Learning.
Oh, yeah. I guess he was saying that his company did not allow their data to be put into Azure. So,
and that's not uncommon for healthcare. In fact, you mentioned earlier that you work for a healthcare company as well, so I'm sure you're familiar with the culture. But that's a cultural thing, and I will say that there are banks and there are healthcare industries, there are governments that are putting their data in the clouds, and they are leaving their competitors behind. So your organization will quickly learn, or they will be left behind.
Yeah. I think that's all the questions we have tonight.
Okay. Well, it was great being here, and thank you for having me.
Thank you so much, Brad. We really appreciate you did all 3 presentations for us, and they're all wonderful, and we did learn a lot from you. That's just great, and I got quite a few people thanking you for the presentation. They did learn a lot. Oh, another one just came in, and he was wondering, can you explain the concept or steps of building test model versus a building production model?
So that's where, honestly, that's where the professionalism is how do you properly distinguish that? And the way I like to do it is kind of asking a couple of questions. So one, we have to ensure that our test model matches a production use case. So just because we have data doesn't mean we should use that particular data. And we have to make sure that the way we build our model for testing and evaluation purposes is identical to the way it would be used in. So, for instance, in our case, we had data about people and their demographic information. So we would have to make sure that when a user logs into our website, we have that information for them. Because it wouldn't be very useful to build a model that requires that information if in our production use case we didn't have it. Mm-hmm. Also, I've seen cases where people want to use interesting data sets that they have that aren't actually available when the production use case happens. So definitely ensuring that the data you're using to train your model is the same exact kind of data it will be able to see when it's used in production is the most important key.
Yeah, I think he also added more comments about what he meant. It's like building test model with sensitive data being encrypted or scrambled versus production with the real unscrambled data.
Oh, well, that's a very interesting use case. In general, you're going to want to use the unencrypted data in your model as you're building it for your testing purposes. With that said, the majority of sensitive data shouldn't be used for modeling anyway, because sensitive data is things like names and addresses and identification numbers. Your web history and your income and stuff isn't generally sensitive in most systems. And if it is in your system, for instance, I can understand why salary or bank account balance might be a sensitive piece of information. You would have to get some sort of workaround for that to know that you have accurate numbers for that.
Yeah, good point. Yeah, Jeff has another question. Could you explain what is a hyperparameter for details?
Sure. So let's pull back up our model here. So if we just click on one of these, we'll click on two-class boosted decision tree because it's the one we've already seen. So a two-class boosted decision tree is basically a mathematical formula. It's a complex mathematical formula, but it's still just basic math. But one of the things that's interesting about it is there are multiple ways to build this math formula. It's not just insert your data and out comes the same answer every time. For instance, we can decide how many leaves will we want in each of our trees, meaning how deep are these trees going to go. We can also decide what's the number of observations you need to create a leaf. And we can also decide how many trees in total do we want to create for our algorithm. And then we have something called the learning rate, which is we're not even going to get into that. But those are all hyperparameters. Basically, they are ways you can tweak the model without changing the fundamental goal of what the model does.
Cool. Any more questions from the audience? I guess that's all we have tonight. Great. It's really wonderful to have you come back and present the 4 tips. There's such a thing as a 3D. Oh, okay. Another question is there such a thing as a 3D best fit?
3D best fit? I can't say I've ever heard that term, unfortunately.
Oh, R-squared linear regression best fit.
Oh, okay. It sounds to me like he's asking, is there a concept for R squared in 3 dimensions? Because our correlations are 2-dimensional objects.
Yeah, he said as opposed to XY axis.
Yeah, that goes a little bit deeper into math than I go. My guess is yes, there is a concept of 3-dimensional correlations. I don't know anything about them. I would just have to assume they exist because somebody's figured it out. But that's the whole point of regression and classification algorithms, is to pare down large amounts of variables into a single variable. So I would say research on your own if you're really interested.
So if you have multiple dimensions, you still need to pare it down.
Well, you don't have to manually do it. That's what regression does. In fact, one of the outputs of a regression model, something called R squared, and that's what he mentioned there. R squared is effectively a multidimensional correlation metric because it correlates all of your dependent variables to your one independent variable via regression. So it is a version of that, but it might not be exactly what he's talking about.
Okay. Well, close enough. Okay, I think that's all we have now.
Okay, thank you.
Thank you so much, Brad. Once I get your slides and the link to your blog, I'll post it on our website. And
okay.
Yeah, and this presentation is recorded and will be posted on our YouTube channel. And if somebody wants to review it, you can look for the emails. I'll send out the emails to those who register for this event. All right, thank you everybody for attending this event, and we'll see you next month. Thank you everybody.